Simplifying. So we're going to get complicated expressions, and we're going to be able to combine certain things, simplify certain things, so that the final solution or the final expression is as simple as possible. So they give us an example here of like geometry. With geometry, do you guys see that triangle on the top of page 228? The triangle there? If I ask you what's the perimeter of that triangle, what are you trying to find? If I ask for the perimeter, it's all the sides added up together. So the three sides that I have to add up together are 5 times the square root of 2, so you can write this down, 4 times the square root of 3, and 2 times the square root of 3. And what did we say we had to do with those three numbers? We had to add them together. And again, when you're adding numbers, does it matter the order? No. So you could have written them in a different order, same problem. Okay, but you're like, I'm not sure how to add these together. Okay, we're going to be talking about what the book calls like radicans. Okay, like radicans. In this expression here, what's the number inside the radicals or under the radical symbol? 2, right? That 2 is called a radicand. What's the radicand in this expression, in this term? What's the radicand here? Okay, are there any terms that have the same radicand? These two right here, right? They have the same radicand. We call them like radicands. If they have like radicands, you can combine them together. And this is how you're going to do it. And do you hear the word I keep using, like? Like radicand, like radicand. It's the same thing as like terms. So these two are like terms. And I might use that more often, like terms. What are the like terms? These two. Do you remember what you add when you're combining like terms? What do you actually add? Do you add the variables together in like terms? No, what do you add? The numbers in front. So here, when I combine these two, I'm actually adding the 4 and the 2. What does that get me? So that gets me 6, and then I keep the same radicand. 4 times the square root of 3 plus 2 times the square root of 3 is 6 times the square root of 3. That's how you combine them. It's like terms. And you're like, wait, what did like terms have? Remember what my definition is of like terms? They have the same variables with the same exponents. Does this have a variable? Does that have a variable? No, but then how am I calling them like terms? Do you remember? Oh man, this is so cool. I love this. 3 square rooted can also be written as 3 to what exponent? Do you remember?
1/2.
To the 1/2. So don't these terms both have 3 to the 1/2? So they have the same variable with the same exponent. So I can just combine those numbers in front. If you don't know that explanation, that's fine. You just got to add those numbers in front. But what happened to 5 times the square root of 2? Can I combine those two together now?
Well, can you combine the 6 and the
Okay, let's see. How many terms are up here now on the second line, I guess? 2. So I'm asking, are these two like terms? Do they have the same radicand? So this is as far as it can be simplified. The only way you can technically simplify more is if you change that to a decimal, multiply by 5, change that to a decimal, multiply by 6, add those two together, that gets you one number, but there's only one problem with that. When you change this to a decimal or that to a decimal, what did you have to do? Think about your calculators. They have to do this. They have to round it. So do you actually get the same exact answer? No, so this is exact. If you change it all to decimals, it would be an approximate. So we want exact. Mm-hmm.
Is there a possibility in like when we get older and like harder math classes, we could have a square root and a square root, so the radicand could be like the square root of 6, but the square root of 7? There is.
Yeah, you can have anything. Good luck with that. Have fun with that later, next year. I mean, in times to come. No, it's not next year. Can't be next year. No. Wait. No, I don't think it's next year. I think that's like pre-calc stuff. All right, let me give you another expression here. It's example 1 on page 228. 3 times the square root of 5 plus 2 times the square root of 10 minus the square root of 5 plus 8 times the square root of 10. Okay, before we get into this, I need to show you a couple things here. How many terms are up there? 4 terms. Okay.
Switch the order.
You can as long as you keep it signed. So what sign does this have? Positive, positive, negative, positive. So you can mix those all around. If you wanted to, you could because of the commuter property. But I need you to look at this before we do anything. Hold on. I want to make sure that these radicans are as simplified as possible. So what you did yesterday, do you remember what it means to be as simple as possible? When the number in here cannot be factored with a perfect square. Is there a perfect square within 5? Within 10? No, what are the two factors of 10? 2 and 5. Neither of those are perfect squares. We already said that one's not. Okay, once you get them all simplified, then I would recommend combining. So they're all simplified. I have 3 times the square root of 5. What's the other like radicand? Yes, and then I'll get your question. Sorry, Nick. Yes. Yep, negative square root of 5. Combine those real quick. Yes. Yes. So you're like, okay, I got to combine these two, but like you said not to change the radicand, and that's true. So what are you actually combining?
1.
There's a 1 in there. So it's 3 plus negative 1, which would get me 2 times the square root of 5. That's how these two combine right here. Okay, somebody tell me how to combine the other two since they are like radicands. How do I combine those? You just add the, you can say even coefficients almost. So add the 2 and the 8, and what do you get? Times the square root of 10. Can you combine these two terms together?
No.
Okay, because they don't have like, what's that special word I've added? Radicand. And let me spell that out here. Radicand. It's a strange word, radicand, and that's the numbers inside the radical sign.
Mr. A, can I like multiply each one? Can I multiply the last one by like 2 over, or just like 2, and then give me
If I multiplied it by 2, I'd get 4 times the square root of 5, because you'd have to multiply the 2 by only this 2. You could make it the same as that if I multiply it by the square root of 2, because then that would be the square root of 10 now. But you would you would change the value of it because you don't have any equations, so you can't even do it to both sides. But you could do it, but it changes the value. All right, let's go to example number 2. See, this is nice and easy, right?
no,
Every time you say that, it gets really hard.
or he just does it hard for me.
No, there's nothing easy. Yeah, there's a hard
All right, this is example number 2, and I need to make sure I wrote it down right.
You did. Yeah, this is like the same thing as the last one. What are you talking
All right,
This is out of it.
remember guys, you got to look for like radicands. So how many terms do I have up there? 4. Which ones are the like radicands? Which ones have the like radicands? The first term and the last term are like radicands. And so what do you have to do with those? Okay, when you add them, be super careful. You're adding negative 4n and negative 5n, which gets you?
Negative 9n.
Ooh, I heard it. Negative 9 n. It's just n. Negative 9n times the square root of 6. Why you don't put negative 9n squared? Because you're not multiplying. You're adding them. So you keep the n as that. It's almost like this, guys. Look at this term right here. It has 3 parts. It has negative 4. It has n, and it has the square root of 6. You know what the like part really is? It's all of this. Don't they both have that? So all you're really combining is the coefficients, which gives you that. Okay, but anyway, we have these two, and they are also like. So what do I get when I add those two? 4n times the square root of 2. Can you combine those anymore? Because they are not like radicans. Okay. Do number 1 on the try these. Number 1. Oh, sorry.
Wait, what are we? Number 1?
On the try these.
Whoa.
All right, I'm going to start asking some questions in about 20 seconds. All right, Matt, how many terms are up there? 4 terms. Sarah, are there any like terms? Yes. Alyssa, what are some like terms?
7 times square root of 15 and negative 2.
Mm-hmm. And what did those two combine to get me, Emma Grace? 4 times square root of 15. Great. The other 2 terms, Caroline, are they like?
Yeah.
They're like, Marissa, so how do I combine them?
You would get 14, or how do you say it? 14
Times the square root of 3, or you could say 14 square root of 3. You just kind of merge it together. And anything else to combine? Okay, look at this one right here. Can you simplify that? This is yesterday's lesson.
Yes.
No.
What are the factors of 15? 3 and 5? Are either one of those perfect squares? No, so you're done with that. Why do I keep asking that? Since up to this point we haven't even had that.
Because you're right.
Because the next problem is going to be.
Because you have these problems. Good job, guys, on this first. This is actually the first fourth of the lesson. Good job. You guys did awesome.
Yay, we finished the first four.
Is that a hint that we're going to fractions?
No fractions yet.
Thanks for those
Yep.
Foreshadowing.
There you go.
No, we don't talk about LA.
Literary devices. Foreshadowing is one of my favorites. How about illusion?
No, please, no. We just had a test on that.
Oh, man. That sounds like illusion.
What are you alluding to?
The test. Okay, anyways.
Mr. Ray, don't mess up math.
It has to be a reference.
Like using
book.
Or something you experience. And this is popular because all of you, or most of you come.
It sounds more like an interjection.
Oh, illusion or allusion? I thought you meant illusion. I'm sorry.
Well, there's
Sorry.
What would you do?
Yeah. Oh, oops.
Wait, what's the difference between the illusion and illusion?
Illusion is visual, like, illusions of you see something but it's not really there. Illusion is referring to something.
It's a poetry.
It's a poetic device. Or it's a literary device. Poets use it. Okay, sorry. All right, here's what we need to do, guys. How many terms do I have up here? I have 3. Are they like terms? No. But that's because they don't look like, just because they don't look like it, doesn't mean they're not. You need to make sure that all of them are simplified, then you can combine. So this is reviewing yesterday. Excuse me. Thank you. Here's the first way we did them, is we just break it down into prime, like if you have, a perfect square, right? So what would come out? A 5 comes out, right? Because the square root of 25. So you get 15 times the square root of 2. Because this came out completely. Comes out. The other way we did it was we did a little factor tree. So 2 times 49. And you could have ended it there, but here I'm going to end up with 2 times 7 times 7. And remember what you do when I have a pair of something? You can get that pair and take it out as 1. Okay, so that pair came out. So what happens with that 7 and that 2? Multiplied to get me 14, but what was left behind? So now I have 15 times the square root of 2 plus 14 times the square root of 2 minus the square root of 2. When I asked you how many were like terms, the answer should have been they were all like terms. But I didn't even know that because they weren't simplified. You're like, do you remember the question I got probably in this room? I know in that other room with the other guys. Why do we do this? Because I don't want to deal with this whole thing all the time. I want to deal with it in its simplified form. Let's pay attention to tomorrow's lesson and we'll get to
But
it.
then when we get to our life, then we're like, why did we do this? Yeah. Usually it's a no.
No, honestly, some things you might not see, like this you may not see in your employment, or you might not take math classes that get further, but you will. But it helps you to think. It really does. It helps you see there's complexity here. Anyway, what are these three now going to combine to get me? 28 times the square root of 2. That's your final answer. Yes, ma'am.
Okay, so bigger numbers like 98 and looking at 80 and 90, I can't automatically see like what goes in and how they break down. How did you know it was 49? Did you just know
Oh,
that?
yeah, I've dealt with that enough to where I know it now. But do you know that 2 goes into it? Yeah, so then 2 goes into 9 4 times. See, this is where, did you guys, I didn't have you early enough. Did you guys learn short division?
Yes.
Okay, if you learned short division, I did that here. That's kind of what you're doing. But if not, I go out here and I put 98 divided by 2, and I get 49. I mean, I could do it.
Sometimes if it's not right. But
We didn't learn this. We did not learn short division.
It says you do it enough. Keep practicing. You don't have to learn it. It just helps on some of them.
We only learned long.
Yeah, we never.
But she probably taught us a little bit.
All right, go ahead and do this one. So you're like, we have no like terms. Well, we kind of do have like terms. But like these two are like terms no matter what. They're going to combine, but I don't know about the other ones. So I'm going to do just different ways. If you do it a different way but come out the same answer, great. We're good.
Only necessarily Roman roads are great.
I'll leave it like that for now. And this one.
Mr. A, did you see Endgame?
I already saw it. Yes.
Did you watch it video?
Yes.
Did you see Iron Man die?
Sorry? Did you see Iron Man?
Have you seen all the
Oh! You didn't see me say that.
Wait, can you separate?
I was forced to say something.
Oh,
That was not good. Has anyone not seen it in here?
I haven't seen it, but I know.
Oh, okay, so then.
I didn't hear what you
you
said.
guys are mean. Okay, now you have to post that online.
That's a spoiler. That can't happen. This video has been discarded. Yes, ma'am.
With the fact that
You just stop the video.
You could, but I have a perfect square. So do I know the square root of 9? It's 3. And then, so that's what you should have gotten. Did you do it another way?
No, I remember that. I got 3, 3, 3.
Yeah. So you took out a 3, and you're left with 2 and 3. Same thing.
You're such a disgrace. You are. Whoa! I think I just saw a fly. You ready?
All right, listen up, guys, so we can get, because there's one more problem I need to go through with you guys, and I want you to pay attention here so you guys know what to do. All right, the 5 comes out. It comes out here, and what does it do with this 5? it multiplies, so it gives me 25 times the square root of 6. That 12 stayed behind. It didn't have to simplify. The next term simplified into 3 times the square root of 6. Negative 6, nothing happened to it. And then this one I left kind of there. What would it become? Sorry, the plus, and then the 2 comes out. 2 times the square root of 6. Excuse me. So I have 1, 2, 3 like radicans.
Wait, there's just a random -6 in there? I didn't even
It was, yeah, it's in the problem there.
So when you do one,
So you do 25 plus 3 is 28.
Plus 2.
Plus 2 is 30. So I'm going to write this maybe down here. 30 times the square root of 6. But then you also have to combine the 12 and the negative 6, which gives me plus 6.
Oh, I got lucky because it was still 6.
Oh, but wait. Do we have like terms here?
No.
They have 6. You got to be kidding me.
No.
That's your fault.
No. That's from Nickelodeon.
wait, it was so easy.
Mr. A, you have to post our video on YouTube.
I am not. I'll post it next year, so there's no spoilers there.
You just got the video.
Just edit it.
Hey, David.
Oh, I will edit it by pressing delete. So now I'll just spoil the whole movie since it's not going to be recorded. Okay, at the beginning.
You're not pressing delete. Yeah, Mr. You're not going to delete this recording. You already spoiled it. You know you can get like sued for that.
Shoo, Mr. A. No, I mean you could. No, they'll just get really mad at you. You can't really because you just
No, you
said
can't.
that.
I heard something about they were spoiling it. Oh, someone got arrested because they were standing outside the theater and yelling what happened.
Well, that's disturbing the public because they're probably being mean about it. All right, I think I'll be done with that. Can't wait to write your homework on the board, but I'll wait. Here's a spoiler. If you're quiet, I'll write the homework up. Awesome. Okay, so your homework tonight, I'm going to give you 2 through 12. Oh. No, I heard all. I was like, okay.
I heard it even if you wanted, but
I heard even.
All right, goodbye, Swivel. Doesn't matter.